Alright, this is screencast number 2 for lesson 1 of unit 4. I'm on page 177. Under the red heading where it says instantaneous speed is the speed of an object at a specific instant. Another description of an object's motion is its instantaneous speed. Remember, we've already talked on the previous page about average speed. Okay, instantaneous speed is the speed of an object at a specific instant in time. For example, when the speedometer of a vehicle reads 88 kilometers per hour, it indicates that the speed of that vehicle the reading on the speedometer changes as the speed of the vehicle changes. Okay, so how can you read instantaneous speed in your vehicle? By looking at the speedometer. Okay, the instantaneous speed may be very different from the average speed. The changing speed of an object can be displayed on a distance versus time graph. The graph shows the distance traveled on the y-axis and the time on the x-axis. As the object moves, the total distance traveled increases with time. A straight line on the graph represents a speed that is not changing. Okay, so we're going to do number 11 together in just a second. Let me get it enlarged a little bit. Okay, I'm looking at number 11. It says, interpret. Using the distance versus time graph, determine the instantaneous speed of the bicycle at 4 hours. All right, so the first thing I need to do is find 4 hours on the graph, right here. In order to know the instantaneous speed at 4 hours, I go directly up from the 4 until it hits the graph. Okay? At this point, it's on this part of the line, okay? And I need to figure out what the speed of that vehicle is during that part of the graph because it's different from the other pieces of the graph. And you notice that they've already given you some information: 10 kilometers per hour, 0 kilometers per hour, 8 kilometers per hour, okay? The instantaneous speed at 4 hours is 8 kilometers per hour because it is part of this straight line, okay? So let me show you guys what we're going to do and how we're going to make sense of this. If you look at the distance versus time graph that they gave you, you can sort of consider that as 3 separate distance versus time graphs all together on one, okay? So there's a distance versus time graph for this first part, because there's a certain average speed for that first part, nice straight line. There's kind of a second distance versus time graph that's attached, this part. And then there's a third distance versus time graph attached. So you can kind of see that it's 3 situations all on one graph. And what we can do is we can look at each part of that graph separately to determine the average speed, what is the speed of that vehicle during that time interval, so that we know how fast it's moving. Okay? All right, so let me show you what I'm doing right there. Okay, so let's look at the first part of this graph, and I just kind of color-coded them. The first part of this graph is this straight piece. Okay, starting at 0 hours, ending at 2 hours. For the distance, it starts at 0 and ends at 20. Well, we know from the previous page that I can calculate the average speed over that time interval if I know the distance and the time. Well, it's 20 kilometers divided by 2 hours. And the line is straight, so there's no variation in the speed during this first 2 hours. So 20 divided by 2 gives me 10 kilometers per hour for that first set of time, well, for that first time interval. Okay. Then in green, you notice this part is a horizontal piece to the line. Okay. It starts at 2 hours, ends at 3.5 hours. Up here, it starts at a distance of 20 meters, and it's still at a distance of 20 meters. So over this hour and a half, we didn't go anywhere. Okay? So the speed here would be a change of 0 kilometers, because 20 minus 20 is 0, divided by a change of time of 1.5 hours. So 0 divided by 1.5 is 0. Okay, that's how they got the 0 kilometers per hour for this part of the graph. Then the last straight piece right here, we're going to investigate and calculate how fast it's going during this part. If you notice, it starts at 3.5 hours. It ends at 6 hours. Okay, 6 minus 3.5, that's a 2.5 hour interval. It starts at a distance of 20 and ends at a distance of 40. That's a change of 20 kilometers. So we take 20 kilometers, divide by 2.5 hours, and we get 8 kilometers per hour. That's how they came up with those numbers. Now, any time, because this little piece is straight, any time between 0 and 2 hours, because the line is straight, we know we're going at a constant speed of 10 kilometers per hour for the first 2 hours. Then, for the next hour and a half, we are stopped. We're not going anywhere because the line is straight and it's horizontal. We've calculated that that is 0 kilometers per hour. Then, at 3.5 hours, we start moving again. Again, it's a straight piece, so we know that we are moving at uniform, constant motion, okay, for 2.5 hours. And we calculated that to be 8 kilometers per hour. All right, over here, I have a couple of really important things that I want you to write down, but let's go ahead and go up here and make sure that we underline all of this stuff under the red subheading too. Okay, under instantaneous speed. Instantaneous speed is the speed of an object at a specific instant. So I underlined the definition of instantaneous speed, the speed of an object at a specific instant in time. It can be observed with a speedometer in a vehicle. I also went to the next paragraph and underlined the changing speed of an object can be displayed on a distance versus time graph. The graph shows the distance traveled on the y-axis and the time on the x-axis. A straight line on the graph represents a speed that is not changing. So for our distance versus time graph down here, we have speed that was not changing for the first 2 hours. Then we have a different speed, but it's not changing over the next hour and a half. Then we have a third speed, and it's not changing over that final 2.5 hours. Okay? Now, I would like you to write down the calculations that I made. Oops. Over here. Okay. The first interval, how did we get 10 kilometers per hour? Because it was a change of 20 kilometers divided by 2 hours. How did we get 0 kilometers per hour for the second interval, or the second part of our graph? It was 0 kilometers of change divided by 1.5 hours. How did we get 8 for the third part of the graph? 20 kilometers was the change in distance divided by 2.5 hours, and you get 8. Please notice and write down that I said that the steeper the line on the graph, the faster the object is moving. So a steeper slope means a greater speed. This slope, this part of this line, is steeper than over here. So I know that the vehicle is moving faster here and not quite as fast here because this slope is not as steep as it is in the first part of the graph. Okay, and using all of that information, we can now make sure that we answer number 11, using the distance versus time graph, determine the instantaneous speed of the bicycle at 4 hours. At 4 hours, it's in this part of the graph, which is a nice straight line, meaning that it is going 8 kilometers per hour the whole time. And that means at 4 hours, it's going 8 kilometers per hour. Number 12, explain the relationship between speed and the steepness of the slope of the line on the distance versus time graph. Well, we just said that up here, so you need to make sure that you also write it down there for number 12. The relationship is that the steeper the slope is, the greater the speed of the object.